So as we talk about a parallelogram, it is a shape in which the opposite sides are parallel and equal to each other, just like what we are constructing here. So shape A, B, C, D. The side AB is parallel to CD and is equal to CD in dimension, and AC is parallel to BD. Okay. The only difference between a parallelogram and a rectangle is that the included angle between any two adjacent sides in a parallelogram, it is not equal to 90 degree. All right. And as we have learned previously, the area in a parallelogram is equal to the base times height. So with reference to this diagram, if I consider the segment AB as the base, let's say the dimension of base is x units, then I say the height is a distance which is perpendicular to the base and is coming from the opposite vertex, opposite to side AB, okay? And that is vertex C in this case, all right? So this is my height in this case. Let's say this dimension is y. So this would be x times y, right? Now, someone will say that I don't want to consider the segment AB as the base. I want to consider the segment AC as the base, and that is perfectly fine to do so. In that case, what we simply do is we will define AC as the base. Let us say that dimension is r units, but we find a perpendicular from the opposite vertex. Let's say I take the vertex B and I find what is that perpendicular distance between the vertex B and the base AC. So in that case, we define that, let's say this height is h. So we say that the area of this parallelogram in that case with reference to the base AC will be r times h. So the height is always with reference to which line you are considering as a base. So with that, let us go and work on some problems related to the parallelogram. Okay, so let's read the statement and identify what we need to find. DL and BM are the heights on side AB and AD respectively. Okay, let's verify that. So this is my AB, and then there is a height DL on this, and then there is a height BM on the side AD. Okay, if the area of this parallelogram is this, we are already given, so the area is 1470 centimeter square. Dimension AB is 35 centimeter. Dimension AD is 49 centimeter. Find the length of BM and DL. So we need to find, let's say if this is my height H1 and this is H2, we are supposed to find these two heights. So we identified what we need to find, okay? And we already have a diagram. So let's put some formulas to it, all right? So we know the area, that's already given to us. So let's put this thing in equation. So area is equal to base times height, right? In this case, the base, if I take that as AD, it is 35, and the height is H1, the distance DL. But I already know what the area is, it is 1470. So from here, I can compute this dimension that will lead me to believe that H1 is equal to 1470 divided by 35. And that comes to be 42 centimeter. So we found this dimension H1, and let's work on the second one. So in the second one, we have area which is equal to 1470. It is equal to the base. In this case, the base is AD, that is 49 times the height, and the height is H2 in this case. Let's label it as red. So this is my height. Simple enough. I have the area, I have one dimension, I need to find the other dimension. So just like the one above, we will say that H2 is equal to 1470 divided by 49. And that comes out to be 30 centimeter. So this was a simple application that we were given two dimensions. We were supposed to find the other two dimensions, the heights. So the point is, for a parallelogram to construct area or to find area, we need the base and the height. The same formula as a rectangle. There can be two heights in a parallelogram. It depends on which base you are choosing. Let us look at another interesting problem related to parallelogram. In this diagram, if AB is 35 centimeter, let's mark the things as we read them. So this dimension is 35 centimeter all the way from A to B, and AD is 20. So this side is 20 centimeter, all right? We need to find the dimension LB. Okay, so we are looking for the distance from point L to point B, this distance, okay? Let's say this is X. And the area of this parallelogram is equal to 560 centimeter square, right? So we need to find this value of x. Let's plan a little bit how you're going to do it. So AB is equal to, if you think, AL plus LB. If I can figure out AL, I can figure out what is LB because I already know what is AB, right? So now let us give a closer look to this shape. We know that DL is a perpendicular because DL is a height from the vertex D to the base AB, right? DL is a perpendicular, that means ADL becomes a right triangle, correct? Once you know the right triangle and once you know this height h, you can figure out what is this dimension AL. And once we know AL, we can calculate what is LB. So this is going to be our approach for solving this, right? So first I need to find h, right? But we know that area is given and that area is equal to the base times the height. Or in other words, it is equal to base is 35 times h. H is unknown to us at this moment. And this whole thing is equal to 560. And this implies that h is equal to 560 divided by 35. And as you do the simple math here, this comes out to be 16 centimeter. All right. And now we can use a Pythagorean principle because AD is the diagonal, h is the height, which is the vertical, and AL is the base. That means AD square is equal to DL square plus AL square. And AD is 20 square is equal to DL. We just found that DL is 16. It becomes 16 square plus AL square. AL is what we need to find. So we will substitute all these values. AL square is equal to 20 square minus 16 square, which is 400 minus 256, and that becomes 144. So from here we can tell that AL square is equal to 144, meaning AL, if you apply the square root on both sides, this becomes 12. Now we know the dimension AL. So AB, that was 35, is equal to AL. From here it is 12 plus LB. LB is x. That implies that x is equal to 35 minus 12, and that equals 23. So this x is equal to 23 centimeter. So with that, we will stop here, and in next tutorial we are going to talk about the triangles.